have this one? Okay.
I'll get it.
Yeah, thank you. Thank you. Thank you for inviting me again, Laura, back there, Fernando, and the rest of the team. And congratulations on your amazing work. And thank you for putting up these kind of meetings, because I think it's essential to give information, reliable information, to not only patients, but also health professionals. So thank you for doing this effort. What I'm going to do today is to try to give answers to the most frequently asked questions that patients ask us, even though we are not physicians, and I want to clarify this from the very beginning. We are a group of biologists, biochemists, chemists that do preclinical research, meaning we work with cancer cells that we grow in petri dishes, in plastic plates, and we work with animal models of cancers, but we don't work with actual patients because we are not physicians. So I'm going to try to answer the questions that we receive from patients, from the bench, from the lab, from what we know from our studies. And when I say we or our studies, I'm not only talking about the research that our group has been doing for the last 25 years, I'm talking about the research that other groups all over the world have been doing in this particular field. So the first question that we get is, of course, I've had cancer, can cannabis help? And before giving an answer to that question, I'm going to spend a few minutes just explaining what cancer is, because you probably understand very well the top part of this slide, but I want to mention something else that we usually forget. And cancer, we use the same word to define more than 200 different pathologies. But all of them share a few things. And the first one is that this process is started when our cells accumulate mutations. They suffer changes in their genetic material, in their DNA, and they lose their controls to proliferate. And they start growing and growing without any kind of control. And they form these tumoral masses that we know as tumors. But this is not all the whole process. There is a second step or second stage in this disease that involves the generation of new blood vessels. Right now, and please don't freak out, we all have little tumors, but they are not a danger for us because they are not going to grow, because we don't have the ability to feed these tumoral masses. They will end up dying, also because we have a very active immune system that gets rid of these masses. But when we are facing a tumoral process, we have a very active angiogenic process, meaning that we are feeding, we are generating new blood vessels that are irrigating these tumoral masses, feeding the cancer cells, and allowing these masses to grow and become a danger for the patient. And there is another additional step at the end of this process that is called metastasis. And this is the generation of new tumoral masses in different places from the primary site. For example, in breast cancer, the primary site would be the breast, but these patients end up having tumors in the lungs, in the liver, and unfortunately, this is the main cause of cancer-associated deaths, not the primary tumors, but the metastases. So this is what we, and most important, oncologists define as cancer, but a cancer patient has to deal with other things that are usually forgotten, like the side effects of anti-tumor therapies, and I have listed here just a few of them: nausea, vomiting, lack of appetite, pain, and I'm sure we all have suffered these episodes once, twice, or we suffer them regularly, but you have to think about this on a daily basis, all day long. And also the psychological effects or the psychological aspects of the disease. Facing a pathology like cancer comes with a lot of anxiety, trouble sleeping, just to mention a few things. So going back to the original question, can cannabis help these patients? The answer is yes, a big yes. And a big yes in part of this slide. A big yes in what has to do with, for example, the side effects of chemotherapy. It has been clinically proved And I'm not talking about our experiments in mice, I'm talking about experiments performed in humans. It has been proved that cannabinoids work reasonably well in preventing the side effects of chemo, specifically the nausea, vomiting, and lack of appetite that these treatments produce. And also they work very well in treating pain, specifically those types of pain that are refractory to standard treatments. And also we know that cannabinoids can work pretty well in anxiety, especially CBD, and they can also help sleeping better, which improves the quality of life of the patients. But what our group has been working on is not this part of the slide, which is very important. We have been working on the top part of the slide, and we have been trying to demonstrate that cannabinoids can work on this part. And we have collected information, collected results, very solid scientific results, showing that cannabinoids can block this part of the disease progression by killing cancer cells. They can also block angiogenesis, and they also block the metastatic process. And what I'm going to show you from now on is just a couple of examples of each of these things. So with cannabinoids, as with any other potential medicine, we have to prove two things, and just two things. It's very simple. We have to prove efficacy, and we have to prove safety. And of course, for cannabinoids, it's not exception. If we want to propose this as a medicine, we have to prove these exact same things. And we have to prove them at different levels. We don't start these experiments with patients. We have to start with the simplest models, cell cultures, cancer cells isolated from the tumors and grown in these plastic plates that I mentioned before. And if our potential anti-tumoral drugs work here, then we move to a more sophisticated and more physiological model, which in cancer is mice. We have different mouse models of cancer. And if things work here, then we are ready to move to the next step, to clinical studies. And as I said before, our lab and all the labs I mentioned work in this part of the research, in what we call the preclinical research. So regarding efficacy, we started working in this field in the late 1990s, and we observed what you can see in these two pictures here. We were working at that time with human glioblastoma cells. Glioblastoma is one of the most lethal tumors. It's a brain tumor. And when we cultured our cancer cells in these petri dishes, we could see images like this one. And these black dots here are cell nuclei, and what you're looking at is a field of cells that are growing happy and healthy in the plates. But when we treated the cells with THC in this particular experiment, what we saw was what you have in the picture on the right. And if you compare the two images, you can see that there are way less few cells in this picture, and they look different. They are round, they are refringent, and these are signs of cell death. In other words, THC was killing cancer cells. We saw these pictures were taken in 1997, and we've seen that in a lot of different cancer types. And this is a list, and I'm sure I'm leaving some cell types behind, but the message is that cancer cells, even though they are so different, they seem to share something that makes them sensitive to cannabinoids. And I'm not aware of any type of cancer cell that do not respond to cannabinoids in this way. They all die when they are exposed to cannabinoids in vitro. So once we obtained these positive results, we moved to the animal studies, and we have done many different approaches, from the simplest one, which consists in injecting cancer cells underneath the skin of immune-deficient mice, to the most complex ones, like this one, where we generated brain tumors by injecting these glioblastoma cells that we used in the previous slide inside the brain of rats, immunocompetent rats in this case. So we were able to generate these white masses. This is a GBM, a glioblastoma, that we generated in the rat. And this is what we observed after THC treatment. This is the very same rat as this one, and as you can see, the tumor has disappeared. And we have seen this not only in brain tumors, but in breast tumors, in skin tumors, in a lot of tumor types. So these two experiments were suggesting that cannabinoids were killing cancer cells, but they were also producing anti-angiogenic responses. Remember that this process is essential for the tumors to become a danger for the patients, and we have proved that cannabinoids can block this process as well. In this experiment, what we did was to inject cancer cells, also GBM cells, underneath the skin of immune-deficient mice, and we can generate masses like this one. And if we treat the animals with THC, we observe what you can see here, a dramatic reduction in size. This has to do with the experiments that I mentioned in the two previous slides. We are killing cancer cells. But when we dissected the tumors, when we removed the tumors from the animals, what we observed was this image here. We see not only a reduction in size, but a difference in color. As you can see, this mass is red, completely red, meaning fully irrigated, full of blood vessels that are feeding the cancer cells, while this tumoral mass, remember, that comes from an animal treated with THC, is completely white. In other words, this is not a danger for the animal because it's not going to grow. It doesn't have a blood supply, an active blood supply, so it doesn't have the tools to be fed. In other words, we were blocking the angiogenesis process as well. And we've seen that not only in GBMs, but also in breast cancer, melanomas, lung carcinomas, etc., etc. You can see that the list is shorter in this case. And it's not because in the other types of tumors we have not seen anti-angiogenic effects. It's because they have not been studied yet. And regarding the latest stages of the disease, the metastasis, the metastatic process, we have proved also that it can be blocked by cannabinoids. In this case, we used another animal model of breast cancer. In this case, we don't have to inject cancer cells. It's a very specific mouse that spontaneously generates breast tumors. So we treated these animals either with nothing or with THC. And in the animals that were not treated, we observed that almost 70% of them developed lung metastases, like in the human pathology. And when we treated the animals with THC, this number was reduced to lower than 20%. So we were blocking, and again, we've seen that not only in breast cancer, but also in GBMs and other types of tumors. So we're blocking the three main stages of the disease by using cannabinoids: uncontrolled proliferation, angiogenesis, and metastasis with the same tool. But are we talking about a safe tool? Are cannabinoids safe? And I'm going to start answering the question again from the preclinical point of view. And the answer is yes. And we have to prove safety at the very same levels that we proved efficacy. So we started with cell cultures. And here you have a representative example of what we get when we challenge cancer cells with cannabinoids versus what we observed when we challenge the non-cancerous equivalents of those cancer cells with the same compounds. In this case, we worked with different breast cancer cells. All these blue and, is this yellow? Yellow bars here on the right correspond to cancer cells. And here we represent cell viability, or in other words, the percentage of cells that remain alive in the plastic plates. And what we want with the cannabinoids is to put these bars down to kill cancer cells. And that's what we do when we use THC in all of them, except in this one. What is the difference between this bar and the rest? The difference is that this bar corresponds to non-tumoral mammary epithelial cells, so the healthy equivalents of all these cancer cells. In other words, cannabinoids selectively kill tumoral cells without affecting the viability of their healthy, let's call them healthy counterparts. This is in vitro. But if we move to the animal models of cancer, do we see any kind of toxic effect? The answer is no. We have never seen any toxicity. Every time we do an in vivo experiment, that's how we call them when we use mice, we send the organs and the tissues of the animals to a pathologist to see if she can find any kind of toxicity, and we have never seen any toxicity in the liver, the spleen, the lungs, the heart, the brain, nothing. So what about humans? Because what I've shown you so far has been made in either cells or animals, rodents. What about humans? Do we have any information about efficacy or safety of cannabinoids for cancer patients in humans? Well, unfortunately, not much. The only high-quality clinical trial that has been conducted so far is this one here. It's a clinical trial promoted by GW Pharmaceuticals. I don't think they need any introduction. And the study was performed in hospitals in Germany and in the UK. The results have not been published yet, but the company made a press release in their website a couple of years ago. And what they said is summarized here. In this study, they treated recurrent glioblastoma patients either with temozolomide, which is the standard chemo drug for these patients, plus placebo, or with temozolomide plus Sativex. And the primary endpoint was to analyze the incidence of adverse events, but as secondary endpoints, they also analyzed the progression-free survival at 6 months and overall survival. And the results, or what they say that they got at that time, was that in the placebo group, the 1-year survival was 53%. In other words, after 1 year, they have 53% of the patients alive. And in the Sativex group, that number went up to 83%. So that's a success already. The median survival was roughly a year in the placebo group, and it went up to 550 days in the Sativex group. And I think this number is now even higher. We've heard, but I don't know if this is true, that these results haven't been published yet because some patients are still alive. So this number is going to be higher and higher. And something that is also very important, especially for doctors that are very scared of the side effects of cannabinoids, is that the number of patients that discontinued the treatment and left the clinical trial was 2 in the placebo group and 2 in the Sativex group, meaning that whatever made them leave the study had nothing to do with the treatment with the cannabinoids. There were side effects, of course. We're not talking about water. We're not talking about something that is completely innocuous. But the side effects were vomiting, dizziness, nausea, headache, constipation. And you can compare that with the side effects of standard chemotherapies, for example. There is another clinical trial ongoing in Australia. And in this case, they are comparing the efficacy of this whole plant preparation with a 1:1 THC CBD ratio versus the efficacy of another preparation where they have more CBD than THC. The control group will be the historical records of this hospital in Australia. And the recruiting process has already finished, and we are just waiting for the results. But we don't know anything about this study yet. So another question that we get from the patients is, can I combine cannabis with my other anti-cancer treatments? And the answer is we don't know. We don't know, but we have some information from preclinical studies that suggest that you can combine them. Again, from preclinical studies that suggest that, but we don't have the answer yet. There are different types of chemotherapy drugs out there. They have different mechanisms of action, and I have just chosen one representative of what we call alkylating agents. And within this family, we have things that are very famous, let's call it that way, among cancer patients, like carboplatin, carmustine, cisplatin, or temozolomide. I have mentioned this drug before. It's the one that they used for the Sativex study, the GBM study. So I'm not going to get into the details, the mechanistic details of how these things work, these drugs work. The important message here is then that when these cannabinoids were combined with one of these compounds, with temozolomide in particular, what they observed, and this was performed by colleagues in our lab, Guillermo Velasco and his group, in GBM, in an in vivo GBM model, they observed that while the animals that received no treatment had tumors that grew exponentially, those animals that received either THC or temozolomide showed anti-tumoral effects that were much, much higher when they combined both THC and temozolomide. And I didn't tell you, but here we're representing tumor volume, tumor size versus time. And as you can see, this is exponential growth, and this is basically not growing, and in some cases the tumors disappearing when combining the treatment. And something very similar occurs when we combine cannabinoids and radiotherapy. A lot of cancer patients are treated not only with chemo but also with radiotherapy. And in this experiment, another GBM in vivo model, they saw that this is the effect of the untreated animals. The tumors grow. They observe a very small, a very tiny antitumoral response when using cannabinoids. No response when using radiation, a very low amount of radiation. And when they combined this very low amount of radiation with this low amount of cannabinoids, the antitumoral response was much, much higher. So this is suggesting, and again, suggesting that combining cannabinoids with chemo or radiotherapy is a better therapeutic approach than using cannabis alone or the other treatments alone. The other question they usually ask is, how should I use cannabis? Should I smoke? Should I vaporize? Should I use suppositories? Should I use topical application? And the answer is, it depends on what you want. If you're looking for immediate relief for some symptoms that you're having, like nausea because of the chemotherapy, like pain, and you need immediate relief, the suggestion would be using something that gets to your system very, very fast. And the fastest way to incorporate cannabinoids into your system in a healthy way is by inhalation. And when we say inhalation, we don't mean smoking. We mean using vaporizers. And as you can see in this graph, when you use this route of administration, you have a peak of cannabinoids in your blood that is very, very rapid, very, very quick. But the problem is that it disappears also very, very quick. So it can help if you have, as I said before, pain, immediate pain, and you want to get rid of the pain. Or if you have nausea. And in that case, this is the way to go. What about if you're looking for antitumoral responses? As you can imagine, you cannot be vaporizing every 5 minutes or every half an hour or even every hour. So you want to do something different. You want to use another route of administration that allows you to have high levels of cannabinoids during more prolonged periods of time. And you can get that by using oral administration, sublingual administration. We have huge veins under our tongue. So if you place the oil, the cannabis oil there, and you try not to swallow, although we all do, but if you try to keep it there until it's absorbed, you will have a completely different experience. It will take longer to peak, so you will feel the effects a little late if you're looking to relieve pain. That is not the way to go. But if you want something that remains in your body for longer periods of time, this is the way to go. Some people ask if they can use topical administration, for example, for skin conditions, skin tumors, or if they have a lump in the breast that is very superficial, they ask if they can use topical administration. And what we tell them is that they have to think about cancer as a systemic disease. You can have a tumor very localized, but the truth is that those cells are ready to escape and to travel and to generate metastases, and you don't want to take that risk. So we always suggest that in conjunction with oral administration, they can use topical administration, but never put all the eggs in that basket, meaning never use only the topical route of administration. The penetration is very, very low, very, very low. When you apply something topically, cannabinoids topically, they don't get very deep, so that's a problem. And also because please think about cancer as a systemic disease, and you have to treat it systemically. And another thing that we get a lot is suppositories, because a lot of patients claim that they can use huge amounts of THC, and I'm talking about huge amounts, like a gram a day, for example, of THC, by using suppositories and not feeling high. And that's probably true, but there is a scientific explanation that they should know, and it's that you feel high when your CB1 receptors in your brain get activated. And they get activated when the THC is in your bloodstream and reach the brain. And if you're not getting high, inserting, I don't know if that's the right word, but you understand what I mean, by using a suppository with a gram of THC and you're not getting high, what your body is telling you is that the THC is not getting to the brain. And if it's not getting to the brain, it's not getting to the tumors either. So in other words, what you are putting into your body is getting out of the body immediately. And that is because the rectal mucosal is not prepared, it's not designed to absorb lipids. It's designed to absorb water-soluble compounds, not lipids. So yeah, you can use a gram a day of THC, but it's not getting to where you want it to get it. So be careful with that. Does it mean that you cannot use suppositories? No. It means that you can use them for specific things. If there's no way you can use cannabis in any other way because you have trouble swallowing or you have any other issues, you can use suppositories. Or if you have local pathologies like rectal tumors or something like that in conjunction with oral administration, but not for a brain tumor, not for a breast tumor, not for things like that. So in summary, and just to finish, cannabinoids produce anti-tumor responses, and I want to stress this out again, in preclinical models of cancer. We don't know if they do the same in patients. There are thousands of anecdotal reports saying that cannabis worked for them, and I'm sure that they did. We don't know if the chemo helped, or we don't know the answer. But as Arno said before, and I think that's a very important message to take home, we have ways to provide the medical community with valid information. And that's not only clinical trials. We need clinical trials, of course. But in the meantime, and that's a message especially for doctors, please collect the information from your patients, because we are wasting that information. We're not talking about a few patients here and there. We're talking about thousands and thousands of patients using cannabis all over the world. And if we collect that information, we can generate the type of graphs that I have shown you for mice, but for humans, to convince the medical community that we have a useful tool and that they can use it. Keep in mind also that cannabinoids seem to synergize very well with the anti-cancer treatments. And at this point, where we don't know if cannabinoids produce anti-tumoral responses in humans, for a fact, we don't know that, it's very irresponsible to suggest a patient to quit standard treatments and go for cannabis-only approaches. And also keep in mind that cannabinoids have additional advantages for cancer patients. They are analgesic compounds or exogenic, meaning appetite stimulant, antiemetic, they work very well against nausea. So the worst thing that cannabinoids can do is to improve your quality of life, which is not a minor thing. And last but not least, and this is also very, very important, cannabinoids have a very, very high safety profile. So I was talking before to Arno, and we were wondering if we would say yes to a cannabis treatment if we were diagnosed with cancer. And my personal answer is yes, I would do it. I have no guarantee at all that it would work for me, not at all. not even myself, I've been working in this field for 25 years, I cannot convince myself that it's going to work with me, even though I've seen thousands of mice being cured by THC. But I know that it's a safe medicine, so I would take the risk. I'm not suggesting anyone to do this. I'm just putting myself in your place and giving a completely honest answer to the question. So thank you very much.
Thank you,
Chair.
Cristina. Great presentation. Thank you. Yeah, we're going to take a seat. We have a number of questions for you.
We have 3 questions so far in the app.
We have 3.
We have 3
If you have
here,
a question, could you please write it in the app? Or if not, that would be the easiest way to do it.
Or we can do it in the end if there's still time.
Okay, the first question, Cristina, is about GW. Is the GW and Australian trials the only ones currently taking place? And are there any new human trials in the pipeline that you are aware of? In the GW trial, there are only 21 patients recorded on the trial. Is that accurate?
Yeah, the numbers are accurate, starting from the last question. Those are the numbers. It's a small clinical trial, but if it works, and it seems that it worked, it will be the first of many, we hope. So, yeah, that the numbers are correct. And regarding the other questions, to the best of my knowledge, those are the only ongoing clinical trials specifically testing the anti-tumor effects of cannabinoids. And other studies in the pipeline, there's one in Madrid that we are, my colleague Guillermo Velasco and Manuel Guzman have been working on the protocol for years, and the permits have been obtained, and the process is now stuck because of the permits to import the compounds, THC and CBD, from Canada. It's not only the permits, but the money that cost to import, and not only to import, but transport, the physical transportation of the compounds from Canada to Europe. It's, I mean, the number is ridiculous. So we are stuck now there because of money issues. And in this study, the patients will be GBM patients. And the difference between the GW study and the Australia study is that they will be newly diagnosed patients, not recurrent GBM patients. So the chances that this study will succeed are higher than when you're dealing with patients that are so sick.
Great, thank you.
Thank you, Cristina.
Next
we have
question.
one more question now, but the next one is from Vanessa Pereira. If the person wants to show herself, just, okay. Yeah, Vanessa Pereira? Yeah, okay, right over there. So in vitro trials, what is the time until cells die with the THC concentration showed?
For in vitro studies, and I usually don't answer questions regarding time or concentrations or doses because people tend to take the calculator and go to internet and try to find how much a mouse weighs and do the maths. If the mouse weighs 20 grams and I weigh 50 kilos, I have to take this much. And that's a very dangerous exercise to do. And it's not that simple. Please trust me. Don't do that because you will end up with a number that is completely crazy. And I would never recommend a patient to do that. But I'm going to answer the question because I assume that you have a scientific background and that you're asking for experiments in a lab. Is that correct? Okay, so in that case, we do the in vitro experiments with what we call small doses, most concentrations of THC within the low micromolar range, and we see anti-proliferative responses as soon as 24 hours. We usually keep our studies for 72 hours, but as soon as 24 hours after the THC exposure, we start seeing anti-tumoral, anti-proliferative responses. But if you want more details, we can talk later, and I will give you more details.
Great. The next question is from Ana Rita Delgado. Thank you. In your experiments with rats, do you have overdose situations? How did you decide the exact dose of THC to use in your experiments?
That's a very good question. We have ways to see if the animals are suffering psychoactivity. We don't ask them, but if they are suffering psychoactivity, they tend to move less and the body temperature decreases. And that happens to them. They recover very, very fast. So it's not something we are concerned about, but it happens. So they show symptoms of psychoactivity. And how did we choose the dose? Well, we started doing these experiments more than 20 years ago. We didn't know much. And we started using 5 milligrams per kg, because that's what people were using in other paradigms, in other tests, for pain, for other ailments, where there was more information available about the effects of cannabinoids. And we started using that much, and then we have changed the dose depending on the route of administrations that we have changed during the years. So that was the rationale behind it.
Thank you. From Rita Teixeira. Yes, right over there. Is it possible that in some circumstances THC can enhance the proliferation of cancer cells instead of killing it?
I'm very happy that you asked that question, because I'm aware that there is a rumor out there in the internet, in the copy-paste Wikipedia that Arnold mentioned before, saying that specifically in breast cancer, in hormone-driven breast cancer, THC can increase the growth rate of tumors. We have never seen that, and we've been looking for that in the lab. What we see is in our in vitro studies, only in vitro, we see that when we use very, very small concentrations of THC, our cancer cells grow more. But exactly, nanomolar concentrations, we see an increase in cancer cell proliferation. When we first saw that, we went immediately to in vivo models, and we used a wide range of doses to see if we could see that tumor increase in effect, and we have never seen that in our hands. We've never seen that, and we have recently conducted a study comparing the anti-tumor efficacy of pure THC versus a full plant preparation in models of the 3 different subtypes of breast cancer, including the hormone-sensitive one, and we haven't been able to see tumors growing more. We've never seen that in vivo, never. Thank you for the questions.
Thank you. We have a lot of questions coming in, so let's see how many we can answer so far. Michael?
Yes. Rita Teixeira? Oh, that was just yours.
That
okay,
was just...
apologies. Jamie de Molinedo. Thank you, Jamie. Do you use isolated molecules, or do you also look into the entourage effect?
Very good question, too. Historically, and you have to keep in mind that we are a cell signaling group, so our goal is understanding how things work. We worked with isolates, with pure compounds, not because we think that is the best therapeutic approach or the worst one. I'm going to be neutral for now in my answer, but because we want to understand how THC works or how CBD works. And if we do these experiments with whole plant preparations, and if we see an effect, we wouldn't be able to know which is the responsible for this effect. So we started, and we've been doing experiments with pure compounds for many, many years. And very recently, we did this small project in collaboration with Mara Gordon. And we compared, as I said before, the anti-tumor efficacy of pure THC versus a whole plant preparation that contained THC plus other things. And what we saw is that both in vitro and in vivo, the extract was more potent than the THC.
Thank you. Nuno Lima. There's a question from Nuno. Well, I'm going to read the question anyway. It says, how long does it take to kill a tumor in the clinical trials you've done, and how much THC was given?
Okay. First of all, we haven't done any clinical trial. Clinical trial is a study conducted in patients, and we are not physicians, so I wouldn't call clinical trial what we do in the lab. And as I mentioned before, I'm not going to answer the question about dosing, because I don't want anybody to go home and do the maths. So if Nuno wants an answer because of scientific purposes, because he's running a lab and he wants to do an experiment with a mouse, I will talk to him very happily. But I'm not going to give a number here out loud, because I don't want a single person to go home and do math with mice versus humans.
Thank you, Cristina. Michael, another one?
Yes, Philippe Gumaras-Torres. Thank you,
Yes,
sir.
right over there.
On a biomolecular level, Cristina, what is the mechanism of the selective effect of THC on cancer cells, and why does it spare the healthy human cells?
That's an excellent question. I didn't include any slide on mechanisms of action today because the audience was kind of mixed, and it was going to be hard for those without a biomedical background to understand a lot of those things. But we do know the mechanism. We know pretty well the mechanism of antitumoral action of cannabinoids. For THC, is basically the inhibition of AKT, which is the master regulator of cell survival in the cells. For CBD, it's slightly different. But going to your specific question, we have no idea why cancer cells die in response to cannabinoids and non-cancer cells do not. We have no idea. We know that it's not the different expression of cannabinoid receptors, because that's the obvious thing that one tends to think. It's not that, because we have healthy cells with CB1 and CB2 receptors and cancer cells with CB1 and CB2 receptors that respond differently. So it's not the cannabinoid receptors. There's something downstream, but we don't know what that is. So part of the group is trying to answer that question.
Thank you, Cristina. Patricia Pacheco? Yes, right there. So do you think THC might have some preventive role? Oh, no, I'm sorry. That's not the question. You presented THC research, but did you have data about the use of CBD?
Yes, we do. And most of the work our lab has done has been performed in breast cancer and in brain tumors, and in both cases, CBD produces antitumoral responses. The mechanism of action is different, but it also kills cancer cells, produces anti-angiogenic responses and anti-metastatic responses. And other groups have seen the same for skin tumors and for other types of tumors. So even though the mechanism of action is different, the final response seems to be the same. And if you combine THC and CBD, in most cases, you get better responses than either using THC alone or CBD alone.
Thank you. Manuel Campos Montero. Thank you, Manuel. Do you think, Cristina, that THC may have some preventive role?
That's also an excellent question, and the answer again is we don't know. But again, coming or getting information from the preclinical setting from animal studies, some authors have seen that in some specific cancer models in which there is an inflammatory stage right before the generation of the tumors, cannabinoids can help to block the progression, meaning can prevent the cancer stage by acting on the inflammatory stage. So I would say that for those tumors that come with a high inflammatory process, it may help. And I'm using the conditional with all the intention because we don't know. But in animal models of cancer that come with a first stage of inflammation, cannabinoids work preventing the generation of the tumor.
Thank you, Cristina. So Leonardo Souza. Yes, right here. In a biochemistry view, how does the cannabinoids know which cells to attack, and how does it act inside that unhealthy cell?
So I think it has already been answered. So the mechanism of action depends on whether you're talking about THC or CBD. And selectivity for cancer cells, we don't know. I hope to have an answer next year, let's say.
That's great. And our final two questions are from Virginia Saraiva. Virginia?
Yes.
Great.
Fine.
Thank you. Okay. We have a question about how THC acts on different stages of cancer. What happens with TNF and T killer cells?
Mm-hmm. There's little information about the effect of cannabinoids on that specific cell signaling pathway, but it has an effect on immune cells. So people tend to think that when talking about cannabinoids, we're talking about immunosuppressant compounds, but I would say that that's not correct. I would use the term immunomodulators. So the effect of the immune system in cancer progression is critical, and cannabinoids don't seem to block the anti-tumoral effect of the immune system, even though they can be immunosuppressants in some contexts. In the context of cancer, it doesn't seem to be a problem.
It was not just a question.
Okay.
If it improves the quality of TNF,
And just a second.
if it improves the quality of TNF, if THC stimulates the production
Of TNF.
of TNF and the T killer cells and so on.
There are some studies showing that THC increases the production of TNF, and that it may be part of the reason why they're killing cancer cells. But there's much less information about that than on the other mechanisms of
Because
anti-tumor.
your presentation was very interesting in practical, empirical terms, but I didn't understand the pathway, how it acts in the different stage of the cancer.
I didn't have time to talk about that, but we do know the mechanism of action. So don't be scared about that. We do know the mechanism of action. I didn't have time to show it, but I'll be happy to share that information with you later.
Thank you.
But we know that THC activates CB1 and CB2 receptors, produces a response that is called reticular endothelial reticulum stress response, and that converts into the inactivation of AKT. And when AKT is inactivated, autophagy is activated and apoptosis is activated. And that's the main mechanism of action of THC. And for CBD, different mechanisms have been proposed, but the main one seems to be the generation of reactive oxygen species. Even though CBD is an antioxidant molecule, in cancer cells, it produces ROS. It produces oxidative stress, and that's the main trigger of cancer cell death for CBD.
Thank you, Cristina.
Thank you.
Thank you very much, everybody.
Thank you very much.
Christina, that was
Thank
fantastic.
you, Cristina.
Thank you so much.